Circular Talks, a podcast hosted by Reynold.
Hi, William. Nice to meet you.
Hi, Arnold. Very nice to be here.
I'm very happy to have you here with us for the Circular Talk. Today, we are going to speak about you and your company, which is Kling. We are very happy to have you here. I'm quite excited to discuss about the topic of today because it's a very large and very important topic into today's world. So the battery is everywhere. Carrying a battery today into the vehicle, into the home, into the pocket with the phones and stuff. So the battery is really exciting to discuss today. The first question I have for you, William, is, who are you and where are you going today?
Very big question. Let's see if I can. I'm William, and I think I would best describe myself as relevant to this topic as very passionate about how do we reuse resources in the best way. I started studying environmental science back in 2014 and quite quickly moved to engineering, mechanical engineering, and did my master's in energy systems, where I kind of focused my master's on batteries and battery degradation, and then wrote my thesis at a company called Northvolt on their recycling side, looking at reverse logistics and collection of used batteries so that they can get to recycling in the most efficient way.
And how, from your studies to Kling, what happened? And now with Kling, where are you going with the company?
Yeah. Kling is founded on a set of beliefs that we hold to be true. And the first one is that batteries is the best suited technology to replace fossil fuels, but they can only be that if they are circular. Like if batteries are single-use items, they are not the best suited technology to replace fossil fuels. To be circular, it's not inevitable. It will not happen by itself. Recycling and circularity is not a circular supply chain that ends with recycling and then that's that. It's very much of an ecosystem with so many different players that all contribute to optimizing the lifetime value or the residual value of products, and in this case, batteries.
Great. So you define yourself, Kling, as a platform, if I'm right. And the platform is often choose to solve circularity issues or frictions. And that's exactly what we do also with Dipli, is that we are solving the supply chain friction with a platform as well. Can you tell us a little bit more about the platform itself? How is the customer journey organized?
Yeah, I think we have to talk about it in contrast to other type of marketplaces and market platforms. So what's the difference with the eBay or Amazon or similar? And I think the core challenge for any company working in the circular industry is the fact that there is no factories. There's no planned supply available, and all the supply that is available is unique because everything, especially batteries, degrade and are used differently. So the platform of a circular platform must help recyclers and repurposers. So anyone who's actually sourcing used products, the platform must help them consolidate and aggregate volumes that is, enough to be interesting for them to build something out of. So from the customer journey, from a buyer perspective, is relatively straightforward. We have built probably the most comprehensive battery database in the world that maps out which cells are used in which modules are used in which packs are used in which cars and other applications. So we can build quite deep data sheets on all the batteries that are out there with static data that doesn't change over the lifetime. We then couple that with the more dynamic data, which is health data, how much have the batteries degraded, and the commercial data as well, which is like where are they, who owns them, what's the price, and so on.
Great. And who is the buyer in this case?
So the buyers are companies who repurpose used batteries mostly from electric vehicles, and they turn it into some kind of stationary energy storage. Whether that is behind the meter, in front of the meter, what they typically do is that they take like an old Tesla battery, they take an old Volkswagen battery, and they put a couple of those together, and they sell that as a energy storage system that can be towards the grid, it can be towards a solar park or wind farm, it can be towards a logistics site, it can be used however it is. So that's a typical demand side.
Great, very clear. To be more specific about the battery that we are speaking of, maybe it's in your case, I feel like it's more about electric vehicle batteries. How do you see the market today of batteries, and why are you going into this EV market? And do you see a bigger market afterwards?
It's definitely enough in the short term. What we see ourselves doing is that we're developing systems and solutions that are enabling circularity. And I believe that they are quite agnostic to the product. And in the long term, we have a self-identity at the company, at Kling, where we want to lead the pursuit of circularity. And I think there's a general idea that the market is slowing down, which is probably true, but that's slowing down from a very, very rapid growth. So the EV market is growing still very, very fast. And I read this newsletter from the EV Universe, which is a newsletter I can recommend. He just did a recent study on the growth of the EV market around the world. And there's now 35 countries around the world that just passed the 5% tipping point for EV adoption in 2023. And that's a typical tipping point for when EVs are generally more accepted, and it's going to grow even faster. So EVs are still growing very fast, but they grew faster before. And what happened is that China has invested a lot into building factories, and they are now just starting to come online. And so you have a production of cells, the core part of an EV battery, that is growing very, very fast. So there is currently a production from China that is satisfying more than the entire global demand for all batteries. That's something that is going to push down prices for EVs, which is very good. And the access for batteries is going to be so much easier to access batteries.
And do you tend to feel that if the price is going down, then there is less attraction to recycle the batteries? Like the cost of a single battery would be lower, and then the first thought would be to buy a new one instead of buying a refurbished one.
Yes, for sure. So there is always the floor price of batteries, which is the raw material content, and there's let's say a rooftop price of new batteries. And so the price of new batteries is coming down, and the floor price is going up because of the interest in recycled raw material. And recycled raw material is being mandated by law that you need to have certain amounts of recycled material in battery production, at least in Europe. And so there's a space in between new battery prices and recycling that is currently held by Second Life, so repurposing, and that window is narrowing. And so the question is that I'm wondering and thinking about a lot at the moment is what's the market for Second Life? What's the market for reuse and repurposing? And I don't know. I think the market will have to, time will tell in the next few years where it's going. But it would be very unfortunate if the unit economics would be the only problem with actually using batteries for as long as possible. You would go into this very short-minded economy, and the battery economy, where you produce very cheap batteries that last for a very short time, and you rather dig up new material from the ground, and then you kind of use the batteries and then don't think about the long-term.
Definitely, yeah. Next, I think a very important topic, and we cannot speak about the battery without mentioning the battery types. There are two main batteries today regarding the materials inside, so the lithium and the sodium batteries. How do you see the market from your side? I mean, on Kling, do you do you process both lithium and sodium batteries, or sodium is not yet ready to be very used on the market?
I mean, lithium ions they've been on the market for 30 years. Sodium is just it's almost like a couple of months old. So or a couple of years at least, but there's definitely a time shift between them. So we almost exclusively see lithium ion. However, our services and our platform and ways of working, it's really agnostic to what type of battery. It can be nickel cadmium, it can be sodium ion, it can be lithium ion, it can be any of the various types of lithium ion. So it doesn't really matter to us. It's just whatever's out there, and we see mostly lithium ion.
Yeah. So at the moment, you don't see that much sodium ion battery on the market yet, because what I read preparing this talk is that inside the EV market and consumer electronics, there is a shift, as you said, at the moment being made, because sodium is having a lot of advantages compared to lithium. The cost of it, so 80% of the cost of the battery is linked to the materials inside it. So lithium batteries obviously have lithium in it, but also cobalt, copper, and these materials are more expensive to create, to outsource, to take out from the ground, and also the human condition of extraction are real bad. So it makes sodium cheaper and also safer for human implicated into the supply chain, and safer when also you carry the battery itself. So I guess the battery transportation, the battery logistics will be easier even for you when the sodium is taking a higher market share. Do you share the same view?
There's a really interesting almost paradox between what you prefer to have when extracting from the ground and what you prefer to have when recycling batteries or any product. When you produce a new battery, you want abundant materials that are very cheap. There's of course little harm when extracted. What happens over its lifetime is that at the end of life, the value of the material in the batteries, it's also very low. It remains very low. And so the incentive for anyone to recycle that is also low. So you rather extract new material than recycle. But if you have high value materials that are has a really high value, then there's a lot of economical incentives for anyone to recycle and extract the raw material. So typically, you want to have, for example, you want LFP, iron-based batteries for stationary, and it's increasing its market share even in the EV space. And LFPs are iron-based, and they have more, obviously more sustainable and more abundant material, which is fantastic compared to NMC or any other cobalt and nickel-based. But at the end of life, it's much better to have nickel and cobalt-based batteries because it's worth to recycle. So the recycling rates for batteries with more precious metals is much higher than those with less precious metals. And this is an interesting paradox. You obviously want more and more sustainable material in the batteries, but it lowers the incentives for recycling.
Yeah.
So there will have to be other forces pushing recycling, like legislative and other reasons for recycling.
Yeah, definitely. And yeah, speaking about recycling, so I guess that when the battery is changed from a vehicle, let's say, because it's time to change the battery because the range is too low, or any other reason, in case of an accident, or I don't know. Anyway, you change the battery. This battery can be used somewhere else with Kling. Is there an option when the battery cannot be used and has to be recycled, like fully recycled, because it cannot be reused somewhere?
Yeah. There's many reasons to that. I mean, you can have a perfectly fine battery that you cannot reuse. You can take the extreme example of, let's say, a Bugatti or a Koenigsegg battery. It's like one battery out there. So the volume available is very, very important to make it economically viable to repurpose anything. So a much worse battery from another more general, maybe low-end EV, the potential for repurposing is much higher because the volume and the total capacity is so much higher. So it doesn't only come down to the quality of that unique battery. It's really a system problem solution. There has to be many batteries that are similar that can together build something new. So it doesn't only come down to the quality of that battery, but also how many there are. And then of course it does come down to the quality of the unique batteries. So if there's 1 million terrible batteries, there might be a chance that they together can build a profitable second life system, but the chances are slim, and then it's just easier to get them to recycling. Here it's also where the raw material content plays a big role. The delta between the recycling value and the repurposing value is much higher for low grade or low material value batteries like LFP, because there's no value. It's almost it's more of a cost to recycle them. So then you prefer to build second life systems. For NMC, it's not as clear cut because the raw material value is very high, and so the raw materials play a very big role. The quality of the batteries and the state of health is very important, but it's equally important, if not more, is the abundance and availability of that supply, and also where that supply is. If it's a million batteries, but a million different places, the cost of logistics and consolidation and testing is probably making it unviable to repurpose or even to recycle. So how fragmented that supply is also a very important thing to consider.
Great. Maybe a question also I had about the recycling itself, about the battery, because it's well known. A lot of people are saying that batteries cannot be recycled, and that's why we need to stick with the vehicle using fuel. I tend to feel that in Europe there are not many recycling expert or warehouse doing these very specific recycling operations for batteries.
It's a lot. It's a large overcapacity in ability to recycle. So there's so much recycling capacity than there is actually supply.
Okay.
So that even more hard to make recycling come off the ground because it's such a high competition. They all compete for the same supply. And so it's an interesting dynamic at the moment where recyclers are looking into second life and becoming repurposers. It's another way to also take care of the batteries and extracting some value from them. So recyclers are now starting to become repurposers around the world. We see that in the US, we see that across Europe, some tendencies towards that in Asia as well. It's quite interesting.
Okay. So how do you see the market? How do you see the future on the market? What's the bottleneck, and what's the big hope that you see in the near future?
There's a natural market development. From today, there's most supply is actually not used batteries or end-of-life batteries or end-of-life vehicles. The biggest supply today is overproduction, causing an oversupply because someone bought too much. You wanted to build a lot of EVs, and then all of a sudden your order book is decreasing, so you don't have to produce as many EVs, and that is causing you to have a lot of oversupply. The entire market is growing so rapidly that every single factory in the world is still improving and fine-tuning their processes. So there's still a lot of off-spec production. So batteries that are not perfectly produced and cannot continue into the car. That's a very large source of supply as well. There's also big recalls for safety reasons that our batteries are taken back. And this is the by far largest source of supply today. But looking, a few years, 10 years ahead, the source of used batteries and actually used EVs is going to be so much larger, because even if you have a scrap rate at a factory that is 10, 20%, 80, 90% are going out on the streets, and they are coming back relatively soon. So that's an obvious market trend, that today the supply is quite consolidated. and in the future, it's going to be increasingly fragmented. So circularity is going to be increasingly difficult because it's going to be so many more batteries and so many more different type of batteries that have been in different cars, they've been used differently, etc., and that reach end of life in a much more fragmented end of life ecosystem. So today, it's possible for circularity to happen to some degree by bilateral contracts between a car manufacturer and a recycler. But over time, there will have to be a system that aggregates and facilitates and enables circularity. And so that's really where we're looking at, is that how can we help the ecosystem? How can we facilitate it? How can we enable circularity by being the platform that really helps the ecosystem as a whole? So timing-wise, we can really help the market to get off the ground and really be circular from the very beginning. And just being in this space at this time, it's a lot of fun. It's very exciting, and it's what we do. But it's very inspiring to hang out with the team, and we see how we continue to develop solutions that is going to be very, very important, even in the very long term. Because if batteries are not, as I said in the beginning, if batteries are not circular, they are not a viable replacement of fossil fuels. And the world has made the bet on batteries. The bet is already made. And so we have to make sure that they are indeed circular.
Yeah. Yeah, makes sense. Well, it was really interesting to have this conversation with you, William, and about you, and also about Kling, of course. Thank you very much. It's really inspiring, and I'm sure that you have a very exciting future, because you are building something that has a lot of impact on today's usage, and so congratulations also to the team. So if we need to follow you and Kling, what's the best advice?
I think we're best at LinkedIn for the moment. You can find Kling Systems at LinkedIn. Otherwise, you can find me at william@klingsystems.com. I'm relatively responsive sometimes. But no, I just wanted to take the opportunity also to thank you for the podcast, but also the space of phones and electronics. I think you've paved the way to show that there is actually a market. There is a market for refurbished phones and for refurbished electronics. And so, thank you for being the trailblazer in that industry. So well done, and thank you for showing the way.
Thanks a lot, William, and good luck, and have fun. That's the most important thing. Have fun.
Yeah, thank you. And you too.